what's up guys? Welcome back to the Mr. Fix-It channel. Today I'm working on my 1990 F-150 and I want to talk about the early EFI systems in these trucks, the sensors that are involved, and how you can test these with basic tools. Stay tuned.
I was sitting out there in the shed one evening, not doing too much of nothing, just kind of staring at the wall. And
okay, now what I mean by basic hand tools is you're going to need a voltmeter. A temperature gun is very handy to have. You're going to need a vacuum pump, a hand pump like this, and using these tools you can test all the sensors on this engine. Now, some of the sensors you will need a more sophisticated voltmeter that will read hertz. These cheap meters will get you by on most of these sensors, anything like this, but if you want to check the map sensor, you're going to need a voltmeter that will read hertz. So using these basic tools, you can troubleshoot the sensors on this EFI system. Now, as a visual aid and a reference, I will be using a Snap-on MT2500 scan tool with these cartridges installed, and you don't have to have this to test these sensors, but if you have the money and you can find one of these for a good price, I strongly suggest this unit for these old EFI systems, because they can do functions like wiggle tests and other things, idle sets, and it's very handy to have, but you do not have to have this. Another handy thing to have while you're troubleshooting anything is an accurate repair manual and a wiring diagram or schematic. This can be key in determining how you're going to be able to fix things. Stay tuned to the end of the video. I will be posting wiring diagrams for multiple years of these trucks, so look for that. So let's get into this. Now, to my knowledge, there isn't a video on YouTube that discusses all these sensors. I did searches all over. You can find a lot of information in the forums, but as far as a all-in-one encompassing video, this is going to be that one video that shows all this information. Now, in the interest of brevity, this video could be very long, and it quite possibly will be very long. So I'm going to do my best to give you the most accurate information as quickly as possible. Some of these systems are quite complex and would take a whole video all on their own to describe how they work and how to test them. So, like I said, in the interest of brevity, I will be giving basic information on troubleshooting on these sensors. Okay, now on this particular F-150, I have the 306 or 4.9 engine. It is been deleted with the smog system, so I no longer have the air pump. There's usually a couple vacuum diaphragms here and a metal tube that runs along here that injects air, and also that I deleted all that system on this truck, but I do have over there another 1990. That one has the 5.0 engine in it, and it still has the thermactic air system in it, so I'll be able to go back and forth between these two trucks. I'll show you where all the sensors are and how to test them with a voltmeter on this truck and on that truck. Hopefully this will help somebody out. I will put up chapters as a breakdown, so if you just want to know how to test just one specific sensor and you don't want to sit through this entire video, look down here on the bottom and you'll see the chapters individualized, and you can just go straight to that. I'll even put in the description timestamps of where each individual sensor is located and tested. So look for that. Alright, so the most important thing you need to find first in your engine bay is going to be the EEC test. Now, on all of these late 80s, early 90s F-150s, it's going to be over here in the brake master cylinder area. It's either going to be on the fender, or in my case, it's in this block. They connect into this little cap that says EEC test right there. This is the connector, and this is what you're going to be using to get codes off of the computer and to do some basic test functions with this. This black piece with these 6 holes in it is described as the self-test output or STO. This little gray connector over here by itself, this is known as the self-test input, or STI. Now to get trouble codes, we need to orient this in this position here, and we're going to number these 1, 2, 3, 4, 5, and 6. Now to my knowledge, all these trucks will not use a pin in location 5. Now some of these trucks will provide live data with the MT2500 snap-on tool, and you will need a couple of these wires that are not included in some trucks that do not give live data. In order to initiate the self-test function, the key on engine off or key on engine running, you will need to use a paper clip or a jumper wire to connect terminal 2 to the self-test input, like so. Okay, at this point you will turn on the ignition, but do not start the engine. This will be the KO/EO test, and you will get your check engine light to flash the codes. The first thing you need to do is make sure that your check engine light comes on when you turn the ignition on. Now I have a video that describes this whole self-test process in depth and in detail, and I'll put a link right up here, so if you're not sure how that whole system works, check out that video and then come back to this video and we'll continue on testing. And if you own one of these old Fords, it's best to have a little test wire like this already set up and ready to go, and I just hang it right here on this bracket, so if I ever have a check engine light come on, it's right there. I can just pop in there real quick and get my code. So okay, these old EFI systems, they do have short-term fuel trims, open closed loop, all these functions that we find in modern day computerized EFI systems. So you need to have all these sensors working and functional in order for this engine to actually go into closed loop, because if you're running this in open loop all the time, you are going to be putting some power left on the table, and also fuel economy is going to be left on a table. Finally, we're getting into it. First sensor you need to check is the engine coolant temperature sensor, or ECT. Now on this 4.9 engine, it is very easy to get to. It is in the thermostat housing through the piping that goes to the heater core. This is the ECT, engine coolant temperature sensor. Now on the 5-liter EFI engines, the ECT is located down below the throttle body, right there. Now this sensor plays a huge role in how the engine computer delivers fuel according to the temperature of the engine. So if you're having symptoms like the engine is hard to start cold but runs good warmed up, could possibly be this sensor. And vice versa, if it starts up good cold but then starts to run bad when it's hot, probably this sensor. Now I'm going to use a voltmeter and the thermal temperature gun that I have to test this sensor. Okay, with the key turned on, I'm going to set my voltmeter to volts DC. I'm going to take my negative lead over to the negative post of the battery. I have the connector unplugged, and we're going to look for the 5-volt reference. Now this won't be exactly 5 volts, it'll be just slightly under or just slightly over, round about 5 volts. And right there I see 4.6 volts, and that is the green wire with the yellow stripe on this engine. Now with the connector still disconnected, I'm going to set my meter to ohms. I'm going to check the resistance of this sensor, and I'm getting a reading of 41.79 kiloohms. Now this is going to be directly related to the temperature, and that's where your thermal temperature gun is going to come in handy. So I'm just going to get a temperature, and right now it's showing me 64 degrees. So 41 ohms is what you should see at a temperature of about 64 degrees Fahrenheit. That is 18 degrees Celsius. This ohms reading will increase as the temperature decreases. The ohms reading will decrease as the temperature increases. So now I'm going to connect the connector back onto the sensor, and now I'm going to go to volts, and I'm going to back probe this connector. And if you do not have leads that will allow you to back probe, you can get these little T-pins or a paper clip that will allow you to back probe this connector. So you're just going to reach in here and you're going to find the wires. It's going to give you a volt reading. So I have 3.18 volts, and this is at 64 degrees or 18 C. Now these numbers are, how do I say this? It's hard to know if these numbers are right without knowing what the baseline numbers is, giving a specific temperature. Now what you can do, we'll move on to the next sensor. You can compare the readings you get from the engine coolant temperature to the air charge temperature, or ACT, or also known as the intake air temperature sensor. On this 4.9, it is in the #1 cylinder intake runner right there on the intake manifold. You can see here's the ECT, there's the ACT. Now you can compare the numbers between these two. Now when this engine is cold, as in hasn't been run, these numbers should be very similar. Now you can take the numbers from this and compare it to the numbers from that, and if they're the same with a cold engine, then you can pretty much verify that both these sensors are working. Or if one is skewed way more than the other, then you'll know that one of these sensors are bad. Now I'm going to go ahead and test the ACT, but before that I'm going to show you where this is located at over on the 5-liter engine. Here's your Schrader valve for the fuel pressure test port on the fuel rail, and just below it, right there, is the ACT on the 5-liter engine. Right there. Okay, now I'm going to do the exact same tests to the air charge temperature sensor. I'm going to pull the connector off. I'm going to set my meter to ohms. So I'm going to probe the ACT. 40.64 kiloohms on the ACT. So that's very similar to the ECT. You also want to check for the 5-volt reference here. I'm going to plug this back in, back probe it, and we should see a similar voltage. Sometimes it's hard to get these leads in there to make contact when you're back probing. You just kind of got to fish around a little bit until you see a reading. Alright, so back probing the ACT, my meter's showing me 3.14 volts. I'm going to go to my Snap-on scanner, and we can see the voltage for the ECT is 3.2 volts at 60 degrees, and the ACT is at 3.17 volts, and that's at 62 degrees. So there is a bit of a discrepancy there as far as temperature is concerned, but one is in air in the intake and the other one is in coolant in the engine. So these are the numbers that you're going to be kind of looking for when testing these two sensors. So these sensors are basically thermometers. It's a resistor that's variable with temperature. So to make it simple, that's all it does is take the temperature. So as a reference, I did get ohms readings of these two sensors when it was at 20 degrees Fahrenheit. And I was getting 91, anywhere from 89 to 91 kiloohms on these two sensors at 20 degrees Fahrenheit. So that'll give you an idea. If it's saying it's reading 91 kiloohms and it's 80 degrees outside or 35 Celsius, then you might think that one of them sensors are bad. So that's one way you can tell if one of these sensors are bad. After I get through all these cold engine checks, I'm going to start the engine, I'm going to run it up to temperature, and we'll get the temperature voltage readings of these two sensors when the engine's fully warmed up. I have a 195 degree thermostat installed in this engine, and I'll show you the differences between the voltages when we get to that point. Alright, the next sensor that is another huge key player in how this engine performs is the manifold absolute pressure, or MAP. And on most of these trucks, as far as I know, they're all located in the same place, and that's over there on the firewall. It has a electrical connector with 3 wires and has a vacuum line leading from the intake manifold over to the sensor. Now just for reference, I'll show you on the 5-liter engine. And as you can see on the 5-liter engine, it is located in exactly the same place. Now same thing here with the map sensor. I have my meter leads back probed into the connector on the 2 outer wires. There's 3 wires. I got it on the left wire and the right wire. This is sensor ground and the 5-volt reference, and you can see I have 4.9 volts for my 5-volt reference. Okay, for this next test of the map sensor, I have moved my red lead over to the center wire. I left my black lead over here where it was at before. I have my meter switched to hertz, and now this is where you're going to have a meter that will read hertz. Now engine off, you should be reading 155 hertz or thereabouts. Now this number will change according to the elevation you are at. So at sea level, this is going to be at about 165 hertz. Where I'm at, I'm about 700 to 800 feet above sea level. Now as the engine starts up, this number is going to decrease, and at idle, like I said, at my altitude, it's going to read at about 100 hertz. Now what we can do to test this sensor is we can disconnect that vacuum line and connect our vacuum pump. Okay, I have my vacuum pump installed, and as a reference, you need to get an idea of what your engine vacuum is at idle. So you would start your engine, connect this vacuum gauge to it, and then it'll give you a number of how much vacuum. And you're going to want to take this pump and pump it up to that same value, which for mine is about 20. And you can see the numbers are falling on the map sensor, on the DOM over there. And you can see I got it up to 20, and see how it fell to almost 100 hertz. Now as you open the throttle, the vacuum will decrease. I'm going to let a little bit of vacuum out of this. You can see how the number's changing as the vacuum drops. So this is how you test the map sensor. Also, when you're testing this sensor, it should be able to hold a vacuum. If it's not holding a vacuum, then this will also indicate that that sensor is bad. Now, having that set to 20 again, looking at my scan tool, you can see that I have 103, 104 hertz with the same vacuum. So the multimeter reading and the scan tool reading are agreeing with each other. Now whenever you're doing checks on sensors that use vacuum and you're getting odd skewed numbers, the first thing you want to do is make sure that the vacuum supply to that sensor is not leaking, disconnected, or another vacuum leak in the system somewhere else, because that will skew the numbers of these sensors that use vacuum. So keep that in mind. Okay, the next sensor we're going to test here is over here on the EGR valve, and this is the EVP, which stands for EGR Valve Position sensor. Okay, for this next test, I moved over here to the 5-liter engine just because this sensor is a whole lot easier to get to with the test leads. And right now I have my test leads in the sensor ground and the 5-volt reference. And when you're testing these sensors, instead of going to the battery negative, sometimes it's better to go to the actual sensor ground. That way you know the sensor is grounded. And if you see the voltmeter here, I have 4.5 volts. That is my full 5-volt reference. What it does is it just simply senses the position of the EGR valve, and to test this sensor, you're going to attach your vacuum pump and you're going to probe the center wire. This is going to give you a voltage of this sensor. You can see that at its resting position, closed, I have 0.357 volts, and as I increase the vacuum and open the EGR valve, that the number will increase. Now you don't want to go over 10 inches of mercury, which is what this gauge reads. And at 10 inches of mercury, I have 4.25 volts, which is almost the 5-volt reference, which means that that valve is almost completely fully open, and the voltage number should decrease as the vacuum is taken away. And again, this is where the scan tool really shines, because on this 4.9 engine, that EVP sensor is so hard to get to with a voltmeter that I can just hook up my vacuum gauge and increase the vacuum and read the voltage right here on the scan tool. So at 10 on this 4.9 engine, I'm reading 4.47 volts at the EVP sensor. Now also, when you're testing the EGR valve, you want to make sure that it will hold a vacuum. If it's leaking, that needle will slowly fall and it will not hold a vacuum. If it's leaking, you need to replace it. With the EGR valve completely closed, I'm reading 0.52 volts. So pretty similar to the 5.0 engine. So if you're having symptoms like the engine runs very poorly while idling, you may have the EGR valve sticking open slightly, and it should be closed at idle. The EGR valve should only be opened at part throttle cruising down the road. So if you're reading voltages that are higher than, say, half a volt when the engine is off or idling, then you may have a stuck open EGR valve. And yet again, if you apply vacuum to that and the voltage reading doesn't change, it may be a blown diaphragm in EGR, or it could be that the EGR valve is stuck closed. So you should get change in voltage as applied vacuum. If you have, say, 1.8 volts on the EVP sensor with the engine off, then you may have a stuck open EGR valve, or the sensor could be bad. Alright, the next sensor I want to talk about here is the oxygen sensor. And on these vehicles, they are heated oxygen sensors. And if you look closely down there on the exhaust, right there is the oxygen sensor. There's only one of them on this engine. And on the 5-liter engine, it is in the same location. And if you look up here by the battery, there is a 4-wire connector. And the wire colors on these are going to change from year to year, make and model, engine design, everything like that. But this 4-wire connector coming up, you can see this is the starter wire coming off of the starter solenoid. This is with that bundle of wires. Now there is 2 circuits here. 2 of these wires is going to be the heater, and 2 wires is going to be the signal. Now to test this sensor, you can do it here, or you can do it down underneath. On this truck, it's underneath the engine, in between the oil pan and the cross member where the connector is. You can connect your voltmeter there, but it's easier to connect up here instead of crawling underneath the truck. But if you had a lift or whatever, you can do it down there. But this is where I'm going to do my testing at. So the first check I'm going to do is I'm going to check the continuity or the resistance of the heater circuit in this oxygen sensor. Now you're going to use your specific wiring diagram to figure out which colors go to what part of this sensor. Now I'm going to set my meter to ohms. Now I know that these 2 wires at the bottom of this connector here are the heater circuit. I'm going to disconnect this connector, and I know that these 2 terminals here are my heater circuit. Now I'm going to get an ohms reading. This ohms reading is going to change when the temperature changes. Now I've had my key on for a few minutes now, and you can see I have 8.6 volts, and it's dropping as the temperature of the oxygen sensor drops. So I've got continuity to the heater circuit. Now I'm going to move on to the signal circuit of this oxygen sensor. Now I'm going to plug this back in. You can also, before we do that, I'm going to switch this to volts, and I'm going to find the power feed to this heater circuit, which I know on my truck it is this dark like purple wire with an orange stripe. I want to back probe that and go to battery negative, and I should get battery voltage. So 11.0 volts on that circuit. So it is, the computer is actually sending voltage to the oxygen sensor. Now I'm going to probe the 2 signal wires, and I'm going to get a voltage of the signal wires. And this can be tricky to make sure you get a good contact in there. 5, almost 6 millivolts on the oxygen sensor. Now when the engine is running, this number should fluctuate from about 5 millivolts all the way up to about 700 or 800 millivolts. So 0.8 or 0.9 would be the highest. Now how this oxygen sensor works is it sees how much oxygen is in the gas, the exhaust gas, and then it tells the computer that it's rich or lean. The lower the number, the leaner; the higher the number, the richer. And with the engine running and the computer in closed loop, this number should fluctuate back and forth, you know, repeatedly, like a couple times a second or more. So we won't be able to get an accurate reading if this oxygen sensor is working correctly without the engine running and warmed up. But we'll do that later. I'm going to do all the engine running tests later, and we'll get those numbers with the engine warmed up and running in closed loop. Now just to show you, on the 5-liter engine, we have the same oxygen sensor connector right here. It's in the same place. Okay, the next sensor we're going to test is the throttle position sensor. Now on the 4.9, it is right there on the throttle body. On the 5-liter engine, it is this connector right here, and the throttle position sensor sits at the bottom of the throttle body down there. Throttle position sensor simply senses the position of the throttle flaps. As you push on the throttle pedal, the flaps open, the sensor gives a reading of voltage to the computer to determine engine load, along with the map sensor. So these two sensors tells the computer what the engine load is at, and that triggers other sensors and does other things. But that's basically how far you're pushing the pedal down. That's what that sensor does. And it is also a 3-wire sensor, so we have our 5-volt reference, our ground, and our signal return. Normally, this isn't always the case, but normally when you have a 3-wire sensor, the wire that's in the center is the signal wire. Okay, I've got my meter leads connected into the TPS. So the 2 outer wires, those would be my 5-volt reference and my sensor ground. You can see I got my 5-volt reference. Make sure your key's on. Key's got to be on for all these tests. You see I got my 4.9 volts. That's my 5-volt reference. So everything's good there. Now I want to move my red lead to the center pin. This is going to give me the outputs voltage of the TPS, and there is a lot of debate on the internet about the voltage of a closed throttle on these TPS sensors, and the real answer is, as long as it's between 5 volts and 1.2 volts, it should be in range. Don't go drilling these things out and twisting and adjusting. A lot of the Mustang guys are freaking out. This has to be 0.98 volts for it to be correct. It doesn't, okay? But that being said, when you open the throttle, this number will increase. And what you're looking for, as the throttle is opened, that you don't get any spikes, jumps, or dropouts in this sensor as you open the throttle. So open the throttle slowly, and you can see the numbers increase. And this is where having a graphing meter comes in handy, because you can see the dropouts much easier. But if you increase the throttle opening slowly, and as long as it's not going back down to 0 or jumping or spiking or doing anything crazy, as you open this, the sensor is probably good. But this isn't a foolproof test, because if you have a very slight dropout in the sensor, it can cause some drivability problems, erratic idle, and some other issues. But usually, as long as you do this pretty slowly and smoothly, which I'm not going very smoothly because I'm holding this meter up here so you can see it, and it's fighting to open this throttle. But there is full throttle. You can see I got almost to my 4.9 reference voltage there at full throttle. And I'm going to slowly back it back down. And like I said, the voltage should drop smoothly as I close the throttle, with no dropouts or blips. And this is how you test the throttle position sensor. Now another way you can do this is you can snap the throttle, as in open the throttle and then let it spring back on its own, and that number should return to the same number. If it doesn't return to the same number, then you have a bad throttle position sensor. Go ahead and replace that guide, because that plays a huge role in how this engine functions. So looking at the scan tool here, you can see that my TPS is reading 1 volt there. On my meter is reading 99.2 volts, so close enough. And again, looking at the scan tool, as I open the throttle, you can see the voltage increase and decrease, just like the ohm meter, volt ohm meter does. Okay, another sensor I want to talk about, and it is very hard to show you, and that is the knock sensor. Now on this 4.9, you can see right there's the distributor. There's the ignition coil. That's the ignition control module. Now just behind that bundle of wires right there on the side of the engine block lives the knock sensor. On the 5-liter engine, it's going to live back here between the intake manifold and the firewall on the back of the engine block, pointing up and down. I cannot possibly show you that, but it should be back there. Now when it comes to testing the knock sensor in these trucks, you can do continuity checks and blah 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 and all that stuff, but the easiest way to do it is to run the key on engine running test, and like I said, described in the link, check that video out. And during the snap throttle portion of that test, it's going to also check the knock sensor. Now if your knock sensor isn't working, it's going to give you a code for the knock sensor. If it's working, you're not going to get a code for it. So if you do that test and you snap the throttle, but you do not snap that throttle hard enough, you will get a code for the knock sensor. So when you do that test, make sure you snap that throttle real quick, as fast as you can, all the way to the floor, and let off quickly, real quick. Don't let the engine rev wildly, blow something up, okay? But that's a way you can test the knock sensor. Other sensors are, like on this 4.9 engine, if you look down here on the side of the engine block, and this again is going to be hard to show you, but right there behind the oil dipstick, that's the oil pressure sensor. This is for the gauge, and technically on this truck it's not a sensor, it's a switch on and off. And if your oil pressure is above, say, like 7 pounds per square inch, then your gauge is going to show that it's got normal oil pressure. Now on the older trucks, it's going to have an actual oil sending unit, and it will look differently. Let me see if I can find one. I think I have one. It's going to look like this, bolted to the side of the engine block. This is an actual gauge. So somewhere around, I'm thinking 88. Don't quote me on that, but I think around 88, they switched to this idiot light style oil pressure gauge. That beeping is just my multimeter timing out. But so if you're reading any oil pressure at all, then your oil pressure sender is actually working. If you're reading low oil pressure, it may not be working, or you may be out of oil, so who knows. So it's nice if you had an actual gauge that read actual oil pressure. So in these trucks, you get what you get. Now on the 5-liter engine, that same thing is going to be, I'll show you where it's at. And this is going to be almost impossible for me to get this on camera for you, but looking down on the driver's side, there's the oil filter, and just above and in front, towards the front of the truck, it is back in there is the oil pressure sender on the 5-liter. Now the last sensor I'm going to show you on this 4.9 engine is the temperature gauge sender. Not to be confused with the engine coolant temperature sensor, and yet again, it's going to be almost impossible to show you, but on the passenger side of the engine, down on the block, actually it's on the cylinder head, underneath the intake manifold, just below the last exhaust pipe, that's cylinder number 6, it'll be sticking into the side of the cylinder head right about there. Now on the 5-liter engine, it's on the top of the engine. So I showed you before, that is the air intake charge sensor there, but the temperature sender for the gauge is actually just forward of that. Right there. That's for the gauge. So it's just below the distributor on the intake. Okay, that's all the sensors. There is a few other components on this that operate the engine via the computer, and that is the actuators. So the first actuator we're going to test is called the idle air control, or IAC, or also known as IAC. The idle air control motor lives on the throttle body. This is this large cylindrical looking thing. It has a 2-wire connector, and what this does is it diverts air past the throttle blades to control the idle RPM. This will bump up the idle speed when you turn your air conditioner on. This will compensate for the power steering pump making a drag, or the alternator pulling extra current. This will keep your idle at a steady state. And this valve right here is a 12-volt DC solenoid. That's where it's at on the 4.9. I'll show you where it's at on the 5-liter. You can see here's the 5-liter engine. The IAC lives right here on the side of the throttle body. Now, testing this idle air control comes with some variables, and I'll explain. Carbon can build up in this valve and skew the amount of air that the computer thinks is being delivered into the engine. So to accurately diagnose this part, you need to remove it. It's held on by 2 bolts and that wire connector there, and it needs to be clean on the inside. Not only does it need to be clean, as it needs to be able to move freely. So make sure it's clean before you do any tests. There is battery voltage going into that plug, and then coming out is the signal return. And to really test this, you kind of gotta just know or have books to reference what voltage is supposed to be at what percentage. And this is controlled by what's called a pulse width, and that is basically the computer switching on and off rapidly to control the position of this valve given a certain engine load. Now, like I said, as far as numbers and percentages, you would need a reference chart, which that information can be expensive or difficult to find. But in this case, there's a couple go, no-go tests that we can do to see if this idle air control is operating. So built into the self-test of this computer, we can jumper those 2 wires on the EEC, run the key on engine off, the key O, EO, and after you have gotten all of the codes and the test is complete, if you open the throttle, you will see the check engine light come on, and when the check engine light comes on, it supplies power to the idle air control, and you'll be able to test whether it's getting power to this control valve. You can use your jumper over there like I showed you before at the beginning of this video, but I'm going to use my scan tool because it's just going to be easier for the purposes of this video. But like I said, if you have more questions, check that link I left in the video before. Okay, so on my scan tool here, I'm going to go to functional tests right here. Now this is going to do the same thing as jumpering the connector over there with your paper clip. So no need to go through that. I have a video that describes that, but I did not put in that video this particular test. So I'm going to select yes. I am going to get a code 67 because I'm not in the truck and I'm not going to be pushing in the clutch, or if it's an automatic, you know, operating the overdrive button. So I will get a code set, but not a big deal. I'm going to go ahead, and this light here will light up and correspond with the check engine light in the dash. So this will be our check engine light here. I'm going to start this test. You'll hear some clicks and the fuel pump run. And right now would be where you would push in the clutch. And this is going to flash your codes. This is going to tell me 67 because I did not push in the clutch. So you count these flashes just like you would with the check engine light. And we're going to wait until this test is completely done. Okay, I got some codes I got to erase in this, but for this video, I'm not going to worry about the codes because I set all those codes. And the scan tool here is telling me to toggle actuators on and off, snap the throttle to check the actuators individually with a DVOM, digital volt ohm meter. So now, once the self-test, the KEGO EO has been completed, the check engine light will stop flashing, and at this point you're going to simply open the throttle. Now remember, this is our check engine light right here. Now when I open the throttle, you can see that the check engine light is on, and we read our volt ohm meter. You can see we have voltage. Now I'm going to do that again. I'm going to snap the throttle, and that'll turn the idle air control off. See that there? So that's how you can test if the power is being sent to this idle air control built into the self-test of this truck's computer. It's easier to do with the scan tool, but you can also do it with a voltmeter. This is easy. Now you can also do this same test. There's 3 more actuators. They're kind of hard to see on this engine way back in there. One is for the EGR valve. That sends vacuum to the EGR valve when the computer demands it. And there's also these 2 other solenoids that go to the secondary air, thermactic air, whatever you want to call that, the smog system. You have the TAB and the TAD. The TAB stands for thermactic air bypass. The TAD or TAD stands for thermactic air diverter. And these are for smog. Because in the state of cancer caused by California, we have this smog pump system. Now what this system is for is to inject air into either the cylinder head or into the exhaust or into the atmosphere, depending on what conditions the engine's under. Now from what I understand from the research, that after a certain time of idling, it will bypass air to the atmosphere, and during driving conditions, depending on combustion temperatures and the O2 sensor, it will bypass either into the cylinder to be burnt through the combustion cycle, or it will divert it to the exhaust to help heat up the catalytic converters. Now on this 5.0 engine, since I can't show you on the 4.9 engine because it has been deleted, these are the air. This is the air intake to the thermactor system. This is the air exhaust to bypass out into the atmosphere. And you have 2 vacuum canisters. One is buried down inside there and is controlled by vacuum from solenoid, and then there's another one behind the engine that is controlled by vacuum. Now here's a closer look because they're easier to see on this 5.0 engine. This is the EVR or exhaust valve regulator. This is what sends the vacuum pressure to your EGR valve. This is the TAD, and this is the TAB. Now that actuator test is going to allow you to check if you probe the 2 wires. Each one of these have 2 wires. When you actuate that test, you'll be able to turn these solenoids on and off using the throttle pedal, and that'll check that these are actually getting power. In order to test if this system is working accurately, you would have to have a scan tool, and you'll be able to determine through scan data what is actually going on. The vehicle has to be running, you have to be driving, and to accurately test all the systems in the thermactic air control, it would take a whole other video, so that is going to be out of the scope of this video. I'm just showing you a neat little test that you can do on board with a paper clip to see if these solenoids are actually being powered on or off. And this is the view from inside the cab of what it's going to look like. I'm going to hit the gas pedal and you'll see the check engine light come on. So that's actuators off, that's actuators on. Okay, for the last actuator, we have what's called the Purge solenoid, and it lives over here on the laying on the intake. It has a vacuum line running from the throttle body down to the charcoal canister. It has a 2-wire connector, and you can also actuate this with the same test to make sure it's actually getting power to it. And where that would live on the 5-liter engine is you would find the vacuum hose going to the throttle body, and it would live down in here. And if you can see here, this one is actually missing, and someone just teed the two vacuum lines together, so it would live in basically the same place on the passenger side of the motor, and have a vacuum line running to the charcoal canister. You see that down in there? So the purpose of the purge valve is, as the gasoline evaporates in the gas tank, if there wasn't a vent in the gas tank, the pressure would expand the tank. So to prevent the tank from rupturing or causing a leak from expansion or contraction, there is a purge valve that allows that. So let me back up. As the expansion happens, the fuel vapors are going to be forced through a line that comes up to the charcoal canister, and the charcoal canister is going to absorb those vapors. Now, under certain conditions, that valve is going to open and allow the engine to draw those vapors out of the charcoal canister and be burnt in the combustion cycle. Now, depending on conditions, that purge valve is going to open and allow. Now, using my scan tool, I was able to determine that anytime that you were on the throttle part way, that valve is going to be in operation, as in it's going to be drawing those vapors out of the charcoal canister and sent into the engine to be burnt. Under some certain circumstances, it will activate the purge valve on engine startup. Now, I haven't been able to decipher exactly when that is. I can only assume it's when temperatures, when the ECT detects certain temperatures, or I'm not sure what, but I do know that you have to be driving the vehicle down the road in order to see that actuator actually open and close. A test that you can do to see if it's actually working is you can hook up a vacuum tee to that line, drive down the road, and see if you see vacuum. And it should not operate at idle, and it should not operate at full throttle. So it's only during park throttle. That's one way you can test that that purge valve is actually doing its thing, so to speak. Now I'm going to start the engine up. We're going to let it warm up, and we're going to check some of these sensors. And this video is already going to be very long, and to save some time, I'm just going to look at the numbers on my scan tool. And like I said before, you can just use your voltmeter to check these systems as they're warming up. And I'm just, like I said, I'm going to use my scan tool to save a bunch of time, so I ain't got to go through and hook up the meter and all that to each one of these sensors, because it shows me all those numbers right there on that scan tool. Standing real close to the camera here, so hopefully you can hear me, and I'm sorry about the glare. Let me back up into the garage a little bit and maybe get some of that glare off the screen. We're just going to have to deal with the glare here, guys. I apologize for that. But I can scroll through some of these data pits. Right now we're looking at this is the oxygen sensor. This is my RPM. This is the throttle position right here. This is my map sensor. You can see it's at 101 Hertz. This just tells me the throttle position closed, part throttle, or wide open throttle. The engine coolant temperature is reading 2.6 volts, and it's dropping, saying 86 degrees. The air charge temperature is reading 2.41 volts, and it's dropping, reading 94 degrees. Idle air control valve is at 60%. It doesn't tell me a voltage, it just tells me the percentage, but the voltage will change as that idle air control valve actuates and does its job. So you can use a voltmeter to see the voltage changing as that idle air control valve operates. It tells me my speed. This is the EVP right here is telling me it's at 0.5 volts, which means it's closed. The EVR is telling me that the EGR is closed. Injection pulse width in milliseconds is telling me how often the injectors are pulsing. It's at 6.29 milliseconds. I'm currently in open loop. Short-term fuel trims are at 0 because I'm in open loop. It's telling me my spark advance is at 24 degrees. And like I said, these numbers are going to change as the engine warms up and gets into closed loop. It's telling me my battery voltage is at 14.2 volts. And it tells me my reference voltage is at 4.98 volts. So this scan tool gives you quite a bit of data. It'll tell you the purge, canister purge is off right now. And the park neutral safety switch or clutch interlock switch, it'll tell you if that's open or closed. So we got all these data pits to choose from, which isn't nearly as many as a modern vehicle, but hey, at least you got that much of it. So when the engine warms up here and goes into closed loop, I'll give you some of the numbers. So I'll come back when the engine warms up. Good old trucks, man. And just in case you were curious, yes, you can put 35, 12, 5, 15 tires on your stock suspension and stock wheels. It just rubs a little bit on the radius arm. Okay, the scanner says I'm in closed loop now, and one way you can tell if you went into closed loop without the scan tool is you're going to look at the O2 sensor. This number should be fluctuating. So I hooked up my meter over here back to the oxygen sensor connector, and you can see the voltage changing from about 0.5 volts all the way up to 0.7 volts. This is one way you can determine is if your engine is actually going into closed loop or not by this oxygen sensor test. Alright, so let's just look at some of these voltages. You can see the engine coolant temperature is up to 182 degrees and the voltage is 0.69, 0.68 volts. So that correlates to 182 degrees Fahrenheit. Not sure what that is in Celsius. Same thing with the air charge temperature, 0.98 volts at 162 degrees. That's the air intake temperature. The idle air control valve is at 42%, and like I said, the voltages on this, like unless you have references to go by, but the voltage will fluctuate as that idle air control valve works. Vehicle speed 0, obviously, because I'm not driving anywhere. The EVR is reading 0 so that it's closed, and that's at 0.51 volts, engine running, warmed up. Now if I snap the throttle, you should see those numbers change a little bit. So that's one thing. If you have your multimeter hooked up to the EVP, you'll be able to see voltage change as you snap the throttle to see if that EGR valve position sensor is working and if the EGR valve is actually moving. The spark, show me my spark advance. The spark advance will fluctuate because it not only uses the idle air control valve, it also uses ignition timing to maintain RPM at idle. The sensors that have 3 wires, you're going to have a 5-volt reference wire, you're going to have a ground wire, and you're going to have a signal return wire. So you always want to check for the 5-volt reference, you want to check for ground. You can do the ground checks by probing the ground wire and going over to battery negative with your ohms meter, or you can set it to volts and go to battery positive while on the sensor ground and check for voltage. So you got to have all three. You got to have the 5-volt reference, you got to have the signal return, and you got to have a ground for these sensors to operate. Now the 5-volt reference wire is basically one wire coming out of the computer, and then there's a splice in the harness that sends the 5-volt ref out to each sensor. So if none of the sensors have the 5-volt reference, then it could be at that splice or a bad connection at the computer. Same thing goes for the ground. The sensor grounds, there's only one in the computer, and they come to a splice and then branch off to all the sensors. So if you don't have a ground on one sensor, it might be an open wire between the sensor and that splice somewhere. This is where a wiring diagram comes in very handy on tracking down where the wires go, the color of the wires. That's kind of how you can decipher if it's a connector problem at the computer, or if it's a broken or what we call open wire between a sensor and the computer. So you always have to have 3 wires on the sensors. Now the sensors that have 2 wires, you have the 5-volt reference coming in and it goes through the sensor, and then the voltage coming out on the other side. So the sensor doesn't have a ground, it's just the 5-volt ref in and then the signal return out. If you don't have the signal return out at the computer, then it might be a connection at the computer harness. I'll show you where the computer harness is located. Okay, looking down below the brake booster here, on the firewall, right there, that black rectangular piece with the bolt in the center is your computer connector. This is where all the sensors come into the computer. Now you can use your wiring diagram and you can take that connector off and you can do continuity checks between the pinouts, and you can find this, the pinouts will be in the wiring diagram for the computer to the sensor, and you can do continuity checks between this and say the EVP sensor over there, and you can determine if you have a broke wire or not. It could possibly even be a bad terminal at the connector to the computer, or possibly it could be the computer itself that is bad. Now to check outputs of the computer, that's another reason to have a scan tool, because the scan tool is going to show you the outputs of the computer right there on the screen. As far as being able to check the outputs and inputs at the computer, you would have to back probe each wire and determine right at the computer harness, and then there's variables in that, because if the pins inside the connector aren't making contact to the pins on the computer, you could be getting confused whether it's a contact problem or computer problem, because the computer has to be connected in order for all this to happen. So if you suspect computer problems, the most common thing that goes wrong with these old computers are the capacitors go bad. You can open up the computer and then replace these capacitors, and there's a ton of videos on replacing these capacitors, and that's usually what goes bad. There is the pin 47, I believe, sensor trace on the board of the computer, and sometimes those get burnt out if a wire was connected wrong or something like that. That could also be a problem if you're having an issue where none of your sensors are returning signals or anything like that. That might be something. You can send your computer off to companies that will repair them. As far as going to a junkyard and getting a computer, you pretty much need to match up a number, and I'll show you what that number is that you need to match up on the computer, because depending on the year and the engine that's involved, the type of transmission it has, the computer is going to be different and it may not communicate with the sensors on your particular vehicle correctly. Now I'll show you what that number looks like so you can match it up with a computer out of a junkyard, or if you're trying to buy one off the internet. Okay, this is the EEC4 computer out of these vehicles, and this particular computer came out of a 1987 F-150 with a manual transmission and a 4.9 liter engine. Now you would think that this computer would run that truck, but it will not, because if you look at your wiring diagram and the pinout here, you'll see real quickly that the pinout is completely different for this particular computer, and the number you need to match is this number right here and this number right here. So these two numbers need to match your truck computer in order for this to work. Now, you may be able to find another computer that will work that doesn't have the same numbers, but it may not operate the engine correctly, or it may not operate the automatic transmission correctly, because some of these old trucks had electronic, EOD transmissions. Some's had AOD, analog transmissions. So when you're buying a computer for your truck, this is one thing you need to check. Now, as far as the pins that I'm talking about, they're in these little holes here. You can see how the wires come out the back. You would need to back probe the back of this connector. This black piece is just held on by some clips, and that can come apart, and you can do your continuity checks between here out through the wires to each sensor individually. Now, another thing, the computer also has to have a ground and a power and a ground itself, and you can use your wiring diagram to determine which pin has the ground. You can see right here it says keep alive power. That's at KAPWR. So there's 3 different main powers. Some of them are powered all the time, some of them are only powered up while the key is on, and there's 3 different main grounds for this ECU to operate correctly. So another thing you can look at is the pins inside the computer. If one of these are bent off or broken, that could cause an issue. But usually the problems with these happen to do with the capacitors inside the computer. These little things here will leak their goo out onto the board and cause all kinds of problems. Now, if this has leaked out and has sat on the board for many years, it has potential of damaging the traces on the board itself, and usually that means death for this computer. There are companies that can bring these back, but if you catch it in time, you just need to replace the capacitor. That's all the further I'm going to go with the computer, because this could take an entire video, if not several videos, to encompass everything that has to do with the computer units in these. There are plenty of YouTubers out there that work on these, tune these, do a search, find out how to work on these and whatnot. Like I said, it's out of the scope for this video. Now, this was a lot of information. Like I said, I'm going to put chapters in here so you can select through, find the sensor you want to test and where it's at. This video is probably going to be an hour long, I don't know. But I tried to keep it as short as I could, plus give as much information as I could. There's a lot more that could be said about a lot of these sensors, but like I said, it's out of the scope of this video. Do your research. I'm just giving you the basics on testing all this stuff. Keep these old trucks on the road and running good. Now, if you guys can appreciate all the effort it took for me to show you all this information, please give me a thumbs up. Consider subscribing. Don't be afraid to fix it. Thanks for watching.